Before I get into the presentation, I would like to take a quick poll and find out which virtual switch you use in your environment. So please raise your hand if you are using virtual standard switch in your environment. Wow. Okay. And how many of you are using distributed switch? Same number? Okay. And how about Nexus 1K? Okay, there are a few. Okay. Actually, what I'm going to do today is give you, this is a standard disclaimer before I get into the agenda. I will give you the overview of distributed switch, and this is really on vSphere distributed switch, and then mainly focus on the new networking features that we are introducing in vSphere 5, and talk about VDS Best Practices. The way I'm going to do it, take an example deployment and how you can design the distributed switch in that deployment. What are the best practices? What you need to consider in terms of physical switch configurations as well as the virtual distributed switch configurations. And there are some VDS myths around. I want to clear that up. So finally that one, and then take questions if you have any. So let's look at the distributed switch. This is the overview. If you see in this diagram, vSphere distributed switch really spans across multiple hosts here. There are 4 hosts in this case. And you can see on the bottom oval there is a physical switch infrastructure which gets connected to the physical host. Now, as you look into the network deployment in virtual infrastructure, there is a virtual networking piece and there is a physical networking piece. Now, in traditional standard switch deployment, you had to manage in every host a virtual switch. But what changes in distributed switch is you have this one distributed switch which spans across the whole data center, and you can manage the single pane of glass. You can manage the whole networking, virtual networking aspects. You definitely have to worry about the physical part later, but at least the virtual network point of view, you have one distributed switch to manage. Also, another thing is the distributed switch is vMotion aware. So what do I mean by that? So if you take a vMotion process, typically a VM which is running on host 1 gets moved to another host 2. If you take a standard switch deployment, really that VM gets connected to a virtual port on that standard switch, and when you move that VM to another host, there is no relation between the virtual port in the standard switch deployment because you have 2 different standard switches, and there is no tracking of statistics, port profiles, and anything like that. That you can do with the distributed switch. So it's a vMotion aware. It provides statistics and policies. So you can have port policies also defined for that particular port. So you have policies at port group level, uplink level, and port level. So with the distributed switch, you can move the port policies also when you do the vMotion. And it helps in debugging and troubleshooting. Then there are advanced traffic management capabilities such as network I/O control and load-based teaming. And I will go a little more detail why you need this network I/O control and load-based teaming features. So this is a diagram which is why network I/O control? Why do you need network I/O control feature? On the left, you can see a standard deployment which you are very familiar with, I guess, where you have a host which has 6 network interface cards in this case. And if you see the network infrastructure traffic, which is iSCSI, FT, vMotion, and all, and also there are VM traffic. So your standard practice is that you allocate a particular traffic type with a particular NIC. And advantage there is that you have guaranteed bandwidth for that particular traffic type. For iSCSI, suppose you have a guaranteed NIC allocated to that. But what are the downside of that? So if you look into this, a typical vMotion, suppose, vMotion doesn't happen all the time. It happens sometimes, and then when vMotion is not happening, the NIC is not utilized at all. You could have suppose VM traffic needs more traffic in terms of bandwidth. You cannot share that with that particular network interface card since you have tied the vMotion to that particular NIC. So if you look at the diagram on the left, where you see the 10 gig deployment, where people have moved from multiple gig interfaces to 10 gig interfaces, where you have done the I/O consolidation. That means you have reduced the number of network interface cards which you have in your environment. You have also reduced the cabling complexity, also reduced the management complexity in terms of physical switches and all. But advantage here is that you have done the consolidation. You have now multiple traffic types flowing through one physical NIC. Now, this is better in terms of utilization. So you are utilizing your network interface card pretty well, because now you are having, suppose vMotion is not using that traffic can be used by somebody else. So this is a better utilization story, similar to what we have been hearing in standard virtualization, like CPU virtualization and all. This is I/O virtualization technology. But there is one challenge here in this case, where you have multiple traffic types fighting for going on one network interface card. There could be, and as Steve Herrod in today's talk about noisy neighbor. And I think noisy neighbor scenario comes into this picture when, suppose vMotion is taking up all the traffic because it's a network intensive process. Then you might have impact on iSCSI and other FT processes. So how can we solve this problem of noisy neighbor? And that's where the network I/O control comes into picture. So network I/O control has multiple parameters, and this is very similar to the resource allocation which VI administrator is familiar with, like CPU resources or memory resources allocated to VM in terms of limits and shares. We have the same concept now for network I/O control, where you can allocate limits and shares for the traffic types. Now, what happens is, so if you say that, okay, I want to limit my vMotion traffic to 2 gigabits per second, or whatever, megabits per second, now you have the capability to do that with the limit capability. At the same time, you have shares. Shares specify maximum, it's a relative importance, really. So what happens is, if you have, for example, if you have two traffic types, take FT and vMotion, and if you gave shares, FT as 100 shares, and for vMotion as 50 shares, what that means is that FT will get twice the bandwidth as vMotion. So this is a relative share distribution in terms of how the bandwidth will be distributed with the network I/O control, the scheduling logic. And so main advantages here is really ability to manage the traffic effectively, so that you can provide the isolation for the traffic types which you have in your environment. And one thing to remember is the shares apply at the uplink level. So if you have two uplinks here, the shares really get applied to separate uplink one at a time. And also limits apply at the teaming level. So I will talk about load-based teaming a little bit more, so that you'll get a better idea in terms of what teaming layer is and how we are providing a unique load-based teaming algorithm. Before going that, just so in terms of benefits, which I anyway talked about, how network I/O control benefits in terms of isolation of your traffic. It is a flexible partitioning method. One thing to remember is that when you provide a shares to any traffic type, suppose there are two traffic types and vMotion is not happening, that shares will be allocated to other traffic type, like FT. So it's not hard and fast traffic limitation which you put in there. So I think recommended practice is not use limits unless you know whether you want to limit the traffic. Use always shares in your distributed switch deployment with the network I/O control. And as I said, so you have a guaranteed service level agreements when you have contention. That means 10 gig pipe is filled. The network I/O controllers make sure that the traffic is provided according to the shares to each of the traffic types. So we support in 4.1 we have six different traffic types: management, iSCSI, vMotion, FT, NFS, and VM. And I will talk more about the addition which we have made in vSphere 5 with respect to these traffic types. So let's look at the load-based teaming. So this is the teaming algorithm based on the physical NIC utilization. So you are familiar with the other teaming algorithms such as source port ID hash, MAC hash, and IP hash. What happens in that particular teaming algorithms is that you get a hash, and then you decide based on the hash output which NIC you want to choose to send the traffic to. So in worst case scenarios, what could happen is that the hash comes out such that all the traffic goes to one NIC. And that is that you are underutilizing other NICs which are there in that team. So what LBT solves that problem is it looks at the utilization and avoids the congestion on one physical NIC, which could happen in the hashing algorithms. So what is the algorithm for the LBT? So every 30 seconds, physical NIC load is checked, which is to find out how much is utilization of each network interface card in that teaming. So if you have two NICs in that team, those NICs are checked for the utilization of their bandwidth and all. And if greater than 75% utilization on TX or RX. So one thing to remember is that normal teaming algorithms works on the egress side. But this load-based teaming algorithm works on both ingress and egress side. So we look at the RX bandwidth as well as the TX bandwidth to make the decision whether the traffic has to be moved or not. So once that decision is when, suppose there is a higher utilization on one of the physical interface card, then based on the amount of traffic you have in your infrastructure, the decision will be made to which traffic to move. And I have an example in the next slide which will give you a better idea in terms of how it works. And also this works with the mismatch speed port as well. So this is the diagram which gives an example where there are three traffic types running in the virtual infrastructure: iSCSI, vMotion, and FT traffic type. iSCSI needs 500 megabits per second, vMotion 700, and FT 200. If you look at the picture on the left, initially load-based teaming uses hash algorithm and hashed iSCSI and vMotion to NIC number 1. And if you see, the utilization of that link is more than 1 gig, because 700 plus 500, it's like 1.2 gig traffic is mapped to the NIC 1. And then the FT traffic is mapped to NIC 2. And based on the utilization of these links, now the load-based teaming algorithm will kick in. And then on the right, so after rebalancing, this is how the traffic will look like. So on the NIC 1 now, only vMotion traffic is flowing, and iSCSI traffic is moved to the NIC number 2. And then you have even utilization on the both the NICs. So just to recap, what are the advantages of using distributed switch? So it's a one single switch across your data center, one single switch to manage, as well as it provides you operational simplicity in terms of tracking your VMs during vMotion, during FT, during disaster recovery and all. You have this debugging and troubleshooting ability with that particular distributed switch, because distributed switch spans across multiple hosts and keeps track about the port information and all. Ability to manage I/O resources efficiently. So with the network I/O control and load-based teaming, you can manage your traffic efficiently. So just since we are on the topic, I want to find out how many of you have really moved to 10 gig deployments. Okay. And do you use two 10 gigs or more than two 10 gigs? So people who are using more than two 10 gigs. Okay. Thanks. So what I'm going to discuss is, the reason I'm asking is this, because when I look at the example deployment, then we will talk about how distributed switch can be configured and what things you need to consider when you make the decision about the configuration for the distributed switch in terms of network I/O control and all. So before going that, let's look into the VSphere 5 new networking features. So there are two main categories of features that are new in VSphere 5. One is network discovery and visibility monitoring features. These features are really addressed to the needs of network administrators. I think you might have heard from your network administrator that I don't have the visibility into your virtual infrastructure traffic. And I can't see what is going on between two VMs on the same host because the traffic never hits on the physical interface. And I can't use my standard tools such as NetFlow and port mirror and collectors and all that stuff. That's what we are providing with this release, the support for NetFlow and port mirror, so that you can monitor the virtual infrastructure traffic as you have a network administrator has been doing with the physical infrastructure. And we also support the standard-based LLDP protocol, which is the discovery protocol. And then second set of features are really enhancement to the network I/O control. So we talked about network I/O control having 6 traffic types and how you can manage the traffic for each traffic type. Now we have the capability to have a new traffic type, which we support new traffic type, which can allow you to define a user-defined traffic types. That means if you have some workloads where you want to make sure that those workloads are important workloads and you want to create a separate traffic type for them, you can do that. Also, we support replication traffic type now. So along with the 6 traffic types, you have these 2 more new traffic types which you can use in your environment now. Also, we support end-to-end quality of service, which is 822.1p tagging. So it's not just enough to provide quality of service or traffic management on your platform. It is important that you carry out that priority out on the physical infrastructure, because congestion could occur in your physical infrastructure as well. So if you have some traffic type which are important, you should make sure that you tag the traffic. And we have this layer 2 tagging capability now, where it will allow you to prioritize your traffic types. And I'll talk more about that in the presentation forward. So let's take a look at little detail in each of these new features. So discovery protocol, as I said, it's a standard-based discovery protocol which allows you to discover the capabilities of neighboring network devices. So if you look at a complex deployment where you have, suppose, tens of virtual switches, standard switches, or I think in case of distributed switches, you will have one distributed switch, but you might have multiple physical switches. Now, to understand the capabilities of those physical switches, you have to have this discovery protocol which allows you to discover the capabilities of that device, as well as it allows you to provide look at the configuration of that particular device. Now, how does that help? So if you look at, if you do as a network administrator do manual configuration of the network devices, it becomes very difficult to, if the VLAN mismatch occurs, then the network will not work at all. So this discovery protocol allows you to automate that deployment process and helps you in deploying complex environments and maintain them properly with respect to the configurations. We support now, so before vSphere 5, we had support for Cisco Discovery Protocol, which allowed you to discover only Cisco devices. With LLDP, now any vendor device can be discovered and configured. So you have Junipers or Brocade or any vendor switch, which you can discover the capabilities of those switches also. Which is this LLDP is standard-based 822.1 AB. So this is a screenshot which provides from the vSphere side. So this screenshot tells us that this vSphere host, where it is connected to, or what is the capability of the switch, physical switch, which it is connected to. If you look on the right side here, link layer discovery protocol, this vSphere has detected that the switch which is connected to has a chassis ID of something, port ID, TTL field, VLAN configuration, as well as MTU configuration. So in this case, there is no VLAN description here, but we support all the TLVs which are required to discover the capabilities of physical switch. What is NetFlow? So let's look at NetFlow. So NetFlow is a networking protocol which collects the IP traffic information and sends it to a collector. So you can see in this diagram, you have a host which has 2 VMs running on it. And now suppose a network administrators want to monitor traffic which is flowing between these 2 VMs. If you want to monitor that traffic, network administrator can create a collector session. And once he so if you look at in this diagram, the physical switch is connected to a collector. So this collector will get the information once you configure the distributed switch for a NetFlow session. So once the NetFlow session is configured, all the flow information between these 2 VMs will be sent out to that collector. So what does collector do with this information? So collector provides you the information about in terms of what are the current top flows in your environment. And as you are doing higher consolidation ratios, or as you are deploying different applications, this feature becomes very important to figure out how many flows are running in my environment, what is going on with them, which are the top flows. And it also helps in capacity planning and all that stuff. And also, you can detect some security issues with your environment with NetFlow capability. So NetFlow usage, as I mentioned here, it can monitor the applications which you have deployed in your virtual infrastructure. It also helps in performance monitoring in terms of how the flows are performing, historical data you collect, and then help you in managing your resources. You do capacity planning in terms of how you can, once you get the data about what traffic type are using, how much bandwidth, you can then configure the network IO control with that feature. So NetFlow capability provides inter-host VM traffic. So what does it mean by inter-host VM traffic? The traffic which is flowing between the VMs on the same host. And also intra-host VM traffic. That means traffic which is flowing between VMs that are hosted on different hosts, as well as VM to physical infrastructure traffic. So NetFlow here helps in looking at all these traffics and helps you send it to the collector and then analyze that traffic. So this is just a screenshot where on the right there are some third-party collectors, And as you can see, these collector tools are very familiar to network administrators in terms of what performance characteristics for each flow are presented to them in terms of and how they can make decision based on what is going on in terms of security issues and all that stuff. So this is really a helpful tool now for a network administrator to monitor the virtual infrastructure traffic. So let's look at the port mirroring. So this is a new feature which we have in vSphere 5, which is similar to the port mirroring capabilities available on the physical switches. So network administrators are very familiar with this capability where they use this port mirroring capability to do troubleshooting, which is this is a little bit different from NetFlow. As in NetFlow, you saw that only flow records are sent, which is not the whole packet. So it's really information about that particular flow is sent to the collector. But in port mirroring case, when you want to troubleshoot your network issues, this capability is very important. So if you want to troubleshoot, some VM is not being able to connect to the external physical world, for example, then you can tap the traffic which is going out of that VM through defining the port mirroring session, and which you can send that information out to external analyzer tools and all, which network administrators are familiar with. So it is also referred to as SPAN, switch port analyzer in Cisco terms. So port mirroring overcomes the limitation of promiscuous mode. So traditionally, when this feature was not available, what were network administrators were doing, or what were VI administrators were doing? They were trying to define one VM in a promiscuous mode and look at all the traffic which is coming in, flowing on that virtual switch, which is very difficult in terms of debugging, because you have to filter out all the traffic and say which traffic I need to really monitor and all. Now you have a granular control in terms of which traffic you want to monitor. So for a particular VM or set of VMs and all, you can create port mirror session and monitor the ingress traffic as well as the egress traffic of a source. So it helps in troubleshooting, as I said. So let's take a look at what you need to do when you define a port mirror session. So port mirror session requires a source, that means which source you want to monitor, and then you want to define where you want to send that packet, which is copied packet, the mirrored packet. And that is the destination. So let's take an example. So we have two capabilities. One, you can choose a VM to a destination. That means on the same host, you can use a VM where the packet can be copied to, or you can copy the packet to the uplink port. So let's take a traffic flow information when you have VM as a destination. So this is an intra-host VM traffic. That means traffic, you have one host, there are 3 VMs running on it, and then if you want to monitor the middle VM, which is the source, what you configure that the VM on the right is the destination VM. So you provide that source where the traffic has to be monitored on, and then the dotted line which shows that whatever traffic is flowing out of that middle VM is copied to the destination. So one thing to remember here is the ingress definition is with respect to the distributed switch. So if you want to monitor traffic which is flowing out of a VM and coming into the distributed switch, that is defined as an ingress source. So in this case, it is, since all the traffic which is sent from that middle VM to the VM on the left will be copied to the destination VM. But suppose you want to monitor the traffic which is coming into the VM, then you define this way. It's an egress source. You define it as an egress source, and the traffic which is sent by the first VM to the middle VM will be copied to the middle destination. And this remains same for the inter-host VM traffic as well as intra-host VM traffic, where traffic is flowing between VMs on the different hosts. So this is another example where, so we looked at when the destination was internal VM on that host. In this case, the destination is an external uplink port, where you have a monitor or analyzer connected to an external physical switch, and you now create a port mirror session such that you can send that mirror traffic out to the uplink port there and send it out to the analyzer which is connected on the physical switch there. Now, we have another config. Suppose you are worried about that mirror traffic might impact the normal traffic, then we have another option where you can separate the mirror traffic only to a specific port. So this is the example where you have 2 network interface cards. So one of the network interface card is dedicated for mirror traffic. So if you are concerned about these impact of the mirror traffic on the normal traffic, you can use this method to separate out the mirror traffic when you do the monitoring of that particular VM or any traffic which is you want to monitor. So let's look at the enhanced network I/O control now. So as I said, there are two new traffic types which you support in vSphere 5. One is the user-defined network resource pool and the new vSphere replication traffic type. So let's talk about the user-defined network resource pool. When do we really need this? So as you are moving towards deploying tier 1 applications in your environment, as in 4.1 we had one VM traffic type. That means all the VMs which you have on that host was sharing that VM traffic type. So whatever shares you provided to the VM traffic type were shared among all these VMs that you have on that host. So as the noisy neighbor issue comes in where one of the VM is taking up all the bandwidth, you might have impact on a tier 1 application. Suppose you have a database server or a voice or IP server running on that, it will have impact in terms of the traffic. So that to avoid this noisy neighbor issue now, what we have allowed you to do now is to create a user-defined resource pool. So it's not just limited one VM traffic type. So you can create 64 different user-defined traffic types. So if you have 4 different applications running on a host and you want to provide isolated traffic for each of them, you can do that now with this. And the new vSphere replication traffic type is really this replication process where if you are deploying disaster recovery and SRM deployment, then we have this new traffic type which helps in that process. And then again, cross tagging to provide end-to-end quality of service, so which is 802.1p tagging. So once you create these different traffic types, now you can say that, okay, this is a voice over IP application traffic, and I want to tag it. So just to go back, so 802.1p tag allows you to tag the traffic into the 7 different categories, so 1 to 7. So if you tag it as 0, then there is no tag really in that case. But if you want to tag a higher priority for that particular traffic type, you can tag it as 7, and then traffic which goes out from the platform to the physical infrastructure. The switch, when there is a congestion in the switch, when there is a congestion in the physical switch makes the drop decision. And when it looks at this priority, it decides that since this traffic is very important, I shouldn't drop this traffic. So it is very important to enable this end-to-end quality of service to use 802.1p tagging. Again, usage, I talked about this. So when your customers are deploying tier 1 application, you can make use of this user-defined resource pool. Also, if service providers who are deploying multi-tenant deployments where they have multiple tenants and every tenant has different requirements in terms of traffic and all, you can use that. So just a diagram which to explain you the tier 1 workload use case. As you see in this diagram, there is a host which has 2 10 gig interfaces. And on the right, you see that total 20 gig bandwidth is available. And that 20 gig bandwidth is shared between the infrastructure traffic type, which are VM, vMotion, iSCSI, and all. And then there is a user-defined resource pool. So what we can do now is there are 3 workloads running on this host. And now we create one new resource group for associating with the workload on the left there. And similarly, we can do it for the workload number 2 and workload number 3. And you can define whatever bandwidth is required for that particular resource group. So this allows you to provide that, avoid the noisy neighbor issues and all that in the tier 1 application deployment case. This is a busy slide, but what I would like you to focus on that. On the left, there are 3 VMs on tenant 1, and there is 1 VM on tenant 2. And if you look at the bottom left corner of the table, and the bottom 2 rows shows what are the shares configuration for tenant 1 and what are the shares configuration for tenant 2. As you can see here that the tenant 2, which has 1 VM, has a share configuration of 50, and tenant 1 has 25. At the same time, the column number 4, which is 802.1p tagging, we are saying that the traffic should be tagged, the tenant 2 traffic should be tagged as 4. So what this means is that in this deployment, the tenant 2 is important traffic. It also gets tagged with higher priority so that the external physical infrastructure treats that according to that. So and this would be a service provider case where multi-tenant use case where somebody has paid more money to get this SLA, and then the service provider can provision that through those capabilities of network I/O control and 802.1p tagging. So let's look at the VDS best practices. in terms of how I will take an example deployment and talk about how you can design the distributed switch configuration when you have this example deployment and what things you need to consider in terms of best practices. So this is the example virtual infrastructure deployment which has rack servers in a 210 gig environment case. I know some of you have more than 210 gigs, but want to address if you have 210 gig network interface card deployment, what are the best practices, and then what you need to consider in terms of physical switch setup deployment, in terms of configuring the physical switch and all that stuff. And also briefly talk about the Blade server in terms of, and it's a little bit different in the Blade server deployment in some cases where Blade servers have these advanced technologies like traffic management through, and it provides them the capability to have a logical PNICs and all that stuff. So we'll briefly talk about that also. So let's take an example virtual infrastructure. And so in this, there are multiple components in this virtual infrastructure, which is there are multiple clusters in a data center, and if there are 100 hosts in your environment, suppose. And then each host has two 10 gig interface, and then you have one VDS which spans across these 100 hosts. And you have physical network infrastructure. So just want to show a diagram so that whatever in the previous slide, whatever components I described does show up in this diagram here, where you have this host which has two network interface cards. And if you look at it on the top, the vSphere distributed switch is spanned across all these hosts. And you have different clusters, so cluster 1 to n. And if you look at the access layer and aggregation layer, there are access layer switches and the aggregation layer switches. Really, when you are connecting your host to an access layer switch, you want to make sure that to avoid any single point of failure, make sure that you connect the network interface card 1 to switch 1 and network interface card 2 to switch 2. Another thing which you want to just point out here is that this is just an example diagram where I have defined port groups. So if you see port group number 1 and port group number 2, which can be associated with different traffic types and can be, as you can see in each of the hosts, these port groups gets pushed down to in terms of the configuration and all that stuff. So just brief, it could be that you might have multiple port groups in your environment. But this is a diagram which helps you to understand what are the components there and how you connect them. So best practice number 1, separate your infrastructure traffic from the VM traffic. I think this is the standard practice. I'm sure everybody is following this in your environment. What are the different methods of doing that? And one is you have a logical separation. And especially in this 10 gig deployment, this is the best way to go because you don't have the flexibility of multiple gig interfaces and ability to do physical separation. So what needs to be considered in the logical separation is now you have one VDS which is spanned across the multiple hosts, and you have these two physical NICs which are two 10 gig interface cards, and you can create separate port groups to do the logical isolation. So each port group can be part of a different VLAN, and then you can logically isolate these port groups. So suppose you have 6 infrastructure traffic. So you create 6 different port groups and assign different VLANs to those 6 infrastructure traffic types. And if you have 2 VM traffic types or 2 different workloads, you can separate out. If you want to separate that logically, you can create that port groups, connect that VM to that port group, and then assign different VLAN to that particular. So that is the best practice in terms of when you have a 210 gig deployment. And I think if you have more than 210 gigs and if you're still worried about security and all that, you could consider that. But it is in this deployment, which example deployment which I'm talking about, really since there are 210 gig, separating traffic types in the physical network is not possible. But I'm just mentioning here, how do you do that? Suppose you want to do that. Then you have to create multiple VDSs. So you can create, as you might be doing with in the standard switch deployment, when you have multiple standard switches, and then each standard switch you are connecting two set of uplinks so that you have the reliability and all that stuff. But that you can, that is the separate physical network infrastructure. But in my opinion, when you have going for 10 gigs, the price point might not be still there that we will have 8 10 gig ports in your environment, and going for logical isolation is the better way to go. So best practice number 2 is avoid single point of failure. So you should make sure that you are connected your physical NIC to separate physical switches. And then understand your virtual infrastructure traffic. So this is important actually. So when you have to configure your network I/O control shares and limits, it is important to understand what is going on in your virtual infrastructure. That means what flows you have in your virtual infrastructure, how much infrastructure traffic is taking in terms of vMotion, FT and all, and how much is the workload traffic. And that you can do that with the NetFlow capability now. So now you have the visibility into virtual infrastructure, how many flows are running there. You can use the NetFlow capability, monitor your virtual infrastructure for some amount of time, a week or months, and figure out how much is the bandwidth for each of the flow. And especially when you are having a tier 1 application deployments or important critical application deployments, having this NetFlow capability helps a lot in terms of measuring that performance on each of the flows, and then taking that data, saying that, okay, I know that now this tier 1 application is using 5 gigs of bandwidth. Then you can say, okay, this many shares are required for that particular flow now. So this is what you can do with using NetFlow, and I think best practice is to use this capability to figure out what are the best parameters for network I/O control configuration. Also, next is prioritize your traffic. Prioritize your traffic to do 802.1p tagging. Through that, you make sure that the physical infrastructure treats the traffic according to the priority, and then helps you to do end-to-end quality of service. What are the physical switch setup configuration you need to take into account? So VLAN setup, when you do multiple, so when we talk about logical VLANs, that means if you are having 8 different VLANs, you want to make sure that you trunk the VLANs through the uplink ports which you are connected to the switch. Spanning tree related things, make sure you enable port fast on the ESXi side. As you know, virtual switch doesn't really participate in spanning tree. So in case there is some security issue and then there is a BPDU sent out, you want to make sure that BPDU guard is enforced, so that STB boundary is enforced, so that if some packets come with BPDU, that switch will just block that packet. Then on the link aggregation, so I think I'm not sure, so there might be people here who are very familiar with the Ether channel kind of deployment where they want to do the load balancing based on combining these multiple network interface cards and using IP hash to do load balancing. In that case, you have to use static. We support only static LACP really. We don't support the dynamic one. And you want to make sure that you have IP hash enabled on the VDS teaming when you are using Ether channel. Another thing is you can use link state tracking, which allows you to detect failures down the hops, so that you make sure that when you have link state tracking, then it allows you to make sure that detect the failure and then move the traffic according to that failures to the other physical interface cards. Make sure the MTU settings match with VDS. In terms of if you are using jumbo frames, make sure that a distributed switch also is configured for jumbo frames, and at the same time, the physical switch are also configured that way. So we have looked at what are the best practices, what you need to consider. So what are the steps in terms of configuring VDS? So there is 4 simple steps which you need to do to configure VDS. One is configure the uplink port groups. So in this example deployment, since we had 2 PNICs, you just configure the uplink port group with these 2 PNICs. That's it. That's what the configuration is required for an uplink port group. Then define port groups based on the number of traffic types you have. So if you have 6 infrastructure traffic types and 2 virtual machine traffic types, total you have 8 port groups to be defined then. And then when you come up with this number of port groups with the logical isolation, then you can define the teaming policy. And preferred teaming policy definitely here is LBT. Use LBT for configuration for this, and configure the VLANs which you have in your environment by talking to the network administrator. And then assign network I/O control shares to different traffic types. So 4 simple steps to configure distributed switch. And you can just add hosts to your distributed switch as you have additional hosts in your environment to add in this. And it just gets all the configuration. So just a diagram, which here I say, and I have this colorful diagram here, which 6. So if you see that there are 8 different port groups, distributed port groups. Each distributed port group is associated with either an infrastructure traffic type or VM traffic type. And on the bottom left here is a table which talks about what teaming option you are going to use there, and what are the shares, and what are the limits. If you want to put limits for the vMotion, you can do that here. So this is a simple configuration steps for deploying a distributed switch environment in your 100-host deployment or whatever number of hosts you have in your environment. So advantages of using network I/O control, just to recap, it provides you dynamic scheduling based on the utilization of your physical NIC. It provides you resiliency through active-active. So what is happening now is, instead of having active standby deployments as you might be having in your teaming option, now you are utilizing your uplinks very efficiently based on the utilization of them. And if one link fails, all the loads will be automatically moved by the load-based teaming algorithm on the other physical link. So better utilized I/O resources and no manual intervention in this case, because the platform will take care of the bandwidth allocation. So this is the blade center deployment. Only difference, if you see in this diagram and the one diagram which I showed in the rack server, is in the blade server deployment, you have blade switches which are really hosted on that blades itself. So the access layer really gets collapsed into the blades itself. All other, in terms of the 210 gig deployment, which is the same as the rack server deployment, remains same. So whatever best practices I talked about in terms of how you think about defining your uplink port group, then how you think about defining different distributed port groups to isolate your logical networks, all these things remain same. Now, only difference is that if you are using Flex10 or UCS with different capabilities, such that you have this logical PNIC representation. That means you have multiple PNICs represented to each of the ESXi hosts. In that case, you need to consider the traffic management capabilities which you have on that Flex10 or UCS or any other blade chassis, what capabilities they have in that. You have to consider that. And I think there was a session with Don Mann. He did talk about it. I'm not sure he's going to repeat next time, but he is focusing on that particular deployment. So you should attend definitely that one. So we talked about all these features, things, and all that stuff. I just want to briefly talk about the two important things in terms of the scalability of distributed switch. So distributed switch can scale up to 350 hosts, and it can have 20,000 distributed port groups. Distributed ports. That means 20,000 VMs you can connect to that distributed switch. As well as you have 5,000 different distributed port groups which you can have, which you can help in terms of logical isolation and all. The other thing is important is extensibility of this platform. So we talked about all this management with respect to the virtual networking. But what happens on the physical network side? That means because virtual networking is very flexible, that means you move things from one host to another host. But physical infrastructure is not that flexible. That means if you have some ACLs and all that configuration on physical infrastructure, you want to make sure that that physical infrastructure can be automatically configured to help them to make the configuration changes on the fly as the virtual infrastructure is moving things around. So to get that flexibility, what we have done is that there is a vCenter API which allows the third-party switch vendors to figure out what are the events going on in the virtual infrastructure in terms of vMotion and all. And if they want to change the configuration of the physical switch, they can do that. So there are some examples with the Arista VM Tracer, Juniper Virtual Control, and IBM VM Ready. These are some of the tools which these partners have built to automate the physical switch configuration when there is a change happening on the virtual infrastructure. So want to make sure that distributed switch is scalable and extensible platform. And you might have heard about the VXLAN, where we are going for how we can simplify the networking world, because networking world is not as flexible as the virtual infrastructure. So to make that network side of it to as flexible as to support the flexibility in the virtual infrastructure, So this VXLAN technology is going to help a lot. And there is a tech preview in the booth, which I encourage you to go and find out how that works.
Are those numbers per vCenter or per distribution?
It's vCenter related. Good question. So some of the VDS myths, which I would like to just clear that up. So one of them is that failure of VC stops all traffic. So Virtual Center is used to do the configuration of distributed switch. So it is used to configure the capabilities of the distributed switch or manage the distributed switch. All the data flow is happening on the individual ESXi host. So if VC goes down, only thing which you cannot do is change any configurations with the port group and all, or you cannot add anything new, but the traffic will continue to flow. Another myth is one VDS is required per cluster. That's not the requirement. And we looked at the case where we have multiple n number of clusters. So if you have 350 hosts, you can have as many clusters you want with how many hosts per cluster and all that stuff. So it's not related with that, is that VDS is required for one cluster. One VDS per cluster is required. You can have multiple cluster and one VDS can manage that. So key takeaways from this session, really we have new features that address network administrators' need of visibility and monitoring. And also with the Tier 1 application deployments, the enhanced network I/O control feature helps you a lot in that. And then make use of network I/O control and load-based teaming to improve your utilization of I/O. VDS is scalable and extensible platform that provides foundation for cloud networking. And so there is some more related information. So there is a hands-on lab which is going on, and you can try definitely the network I/O control, NetFlow features are there. Port mirroring also is part of that lab. And there is a networking blog. You can follow that, any discussion if you want in there. And also there are some sessions which you might be interested in. In the afternoon, there is a session from product manager Milan Desai about the virtualization aware data center. He will talk about the VXLAN there. So any questions? Open up for any questions. Thank you.